Okay, hello everyone. So today we are going to move to the new section, which is we move to the VLSI subject. Okay, and today we have a new topic of inverter schematic simulation. So inverter schematic simulation, you can see in the MST Lab 7. Okay, Lab 7 inverter schematic simulation. So you need to download this software first. All right. So in this software, after you download it, okay, you can see the software. We have two software over here, the HCH 35 and Microwind 35. Okay, and also I send you the manual. Okay, you can find in the MST. So now we move to the lab 7. Okay, for this week, 20th May 2021. And next, you can see in this manual, I already provided all the information how to start. Okay. All right. So before we start the lab, I would like to in brief. Okay. I would like to brief what you need to do for this lab. So you need to generate the inverter schematic using the HCH microwave software. Okay, which is this software, the HCH 35. So when you open it, you can see there are 5 folders, the SH35 examples, HTML, IEEE, and rules. Okay, so you can move to the SH35 to open the software. Okay, this one, the SH35. Okay, so you can see the software is open right now. So there are 5 toolbar, 6, 1, 2, 3, 4, 5, 6, file, edit, insert, view, simulate, and help. All right. So move back to the manual. So you need to draw the inverter, CMOS inverter. This is the basic component in the CMOS technology. So only one component here, which is the NOT gate. Okay, the NOT gate equal to the inverter. All right. So that's mean when you put 0 or off here, your output should be on or 1. And if your input is 0, okay, so you can get the output 1. And if your input is 1, your output will be 0. And you need to know the schematic diagram. Okay, the schematic diagram of the inverter should be like this. So it consists of two components over here. We have PMOS and NMOS. Okay, PMOS and NMOS. So next, all right. So here, this is the board. Okay, the board of the circuit. As you can see in this the HCH. Okay, so this is the platform how you can place, drag, okay, all the component in this platform. Number one, what you need to do is you can find the component over here. I think you need to click this run simulation. Okay, this run simulation to open it this toolbar, which is consists of all the parameters or all the components of the schematic components, schematic diagram. Okay, so now you need to insert the input over here. This is your button of input, and this is your supply. This is the ground, and this is the PMOS, and this is the NMOS. Okay, so exactly you need to draw like this diagram. So we have PMOS, we have NMOS, we have input, we have the supply, and we have the ground, and we have the output. Okay, so you need to draw exactly like this. Okay, before you start, all right, so basically in this in this simulation, we need to eh, select the boundary first. before you start. Select the foundry. So now we are going to use the 0.18 technology. So basically, this is the several technologies which is you can obtain from these rules. Okay, these rules in your folder. Okay, you can see the rules folder. So there are, I think it's around 7 technologies. Okay, 7 technologies. But for this class, you can use 0.18 technologies. It doesn't matter. You can use any technologies. Okay, any rules. But for this class specifically, you need to use DCMO 0.18. Okay, please remember, before you start the simulation, please select the foundry properly. Okay, open, and you need to save. Okay, you can save anywhere, right? For example, this is for lab 7. And you can name as inverter. Okay, inverter. Right, so now you already saved and you already selected the correct foundry. Okay, the technologies is 0.18. Okay, now we can move to the uh, dragging. Okay, dragging the components. So you should have the supply over here, and you should have the PMOS over here. Okay, and you should have NMOS over here. Okay, so after you drag all this component, and finally we will have the ground. Okay, and also you must have the input over here and the output. The output should be the LED. Okay, this is your LED. Is to represent your output. Okay, and after that you can select the wire to connect the components. Everything should be connected. Okay, so now you already draw the inverter. So this is the schematic diagram of the inverter. And next, you can start to simulate. Okay, you can start to simulate. So here, you can see the simulation control over here. Okay, and you can click on this. This one, the input is 0 and the output is 1. You can see the LED is turned on. So you put the input is 0. Oh, sorry, you put the input is 1. So the output is off or 0. And you can keep on playing to see the result. Okay, and finally, after that, you can click on this stop simulation and you can check the timing diagram. So this is the result of your inverter simulation, your input and your output. Okay, this is 0, this is 1. Okay, you can enlarge I think you can enlarge the result here. Oh, this is the maximum point. Okay, I think you cannot enlarge the result, but okay, yes, we all. Now you can enlarge the result until the maximum point. So you can see this is how you keep playing the input and output. Okay, the input and output. So when the input is 1, the output will be 0. And when your input is 0, the output will be 1. Okay, so you need to snapshot this result and put in your reports. Okay, this is how we draw the inverter. Okay, so after that, you can check in this manual. We have the exercise for you. Okay, design and simulate of a two input NAND and NOR gate using the HCH software. So how to find the correct schematic of NAND or NOR using the HCH? So basically, when you want to draw these components, So you can go to the Google, I think, and you can type it non-schematic. So you can find the correct figure of the non-schematic, which is like this. Okay, up to you. If you know how to draw the component, you can directly proceed the drawing. If you don't know, you can refer to the Google. Okay, so basically this is the digital logic NAND gate. So this is the two input. I think this one the two input. Okay, the two input A and B of the NAND. So you can draw this figure. So and then you need to simulate and find the timing diagram. And after that, capture the result and send as your report. Okay, so I think that's all for this class. And if you have any issue, you can text me. Right? Okay, so thank you very much.